Rightio. Welcome back to Mr. Robinson and his creaky chair. Today, as you can see, we are writing chemical equations from worded questions. We have a look. There's our first one. I am going to show you at the end of this video a list of acids and some tips and tricks. I'm going to move the document camera. It's going to be awesome. But apart from that, let's get started. So it says here when lithium hydroxide. So the first thing we need to be able to do is write down what lithium hydroxide is. So lithium and then a hydroxide. Now if we check this, we know that this has a valency of +1 and that hydroxide has a valency of -1. So they'll go together fine. We don't need any brackets, we don't need any numbers in this particular compound. And then it's added to sulfuric acid, so H2SO4. Now that's the symbol for sulfuric acid. And you will see, of course, that there are a list of acids at the end of this video if you don't know what they are. So what type of reaction have we got? So the question could come in two forms. It could come along and that could be the end of it. And you're, of course, looking so from there down to here and hoping that you recognise that we have an acid and we have a base. So this is going to be a acid-base reaction, or the other word for it is a neutralisation reaction. But in this particular question, it actually tells you that we're going to form lithium sulfate. Now, a sulfate is -2 and a lithium is +1, so this is going to need to have a little bit of a 2 there. I need to just rub that out. I'm running out of room. And we're going to form water, so H2O. And I'll see, can I just fit that on? Oh, maybe just. Oh, that was close. So, we've managed to combine these to create a chemical equation. So can we say that this chemical equation is balanced? Well, we have a look. Obviously, pretty sure you might have seen that we have 2 lithiums here, but we only have 1 lithium here. So it is not balanced. Now, in this particular case, because our OH here has actually split, or our hydroxide has split into water, we are going to have to break this down to all its different elements. So lithium, oxygen, sulfur, and of course hydrogen. So making sure that I list them in the same order on the other side, just so I don't get confused, and then we'll get to balancing. So I've got 1 lithium here and 2 lithiums there. Now if you want to pause the video at this particular point and do this yourself and then check the answers, I would probably recommend that. It's going to be a good way for you to practice this particular thing. So if we have a look, how many oxygens? Well, 1 here and 4 there makes 5 in total. 1 sulfur, there it is. Don't get mixed up with this 4. The sulfur doesn't have a number associated with it, so it's only a 1. And then, of course, 3 hydrogens that we have here. On this side, we have 4 oxygens plus 1 is 5 oxygens. We've got a sulfur and we've got 2 hydrogens. So we have a look. No, it is definitely not balanced. So it doesn't matter where we start, but in this particular case, I'm going to start here with our lithiums. So I'm going to put a 2 here, which is going to change it to 2 lithiums, but it's also going to change a lot of other things in this. So if we have a look, I have 2 oxygens plus another 4 over here, changes this to 6 oxygens. 2 hydrogens plus 2 hydrogens over here, change it to 4 hydrogens. And of course, I've still got my 1 sulfur. I haven't put any numbers here to change that. So I've still got 1 sulfur on this particular side. So now I'm out of whack for both oxygens and hydrogens. Well, I'm actually going to come over here and I'm going to balance for hydrogen first. So I'm going to put a big 2 here because 2 times 2 will give me 4 hydrogens. And now these 2 are balanced. Oh, well, would you believe it? It's actually balanced it for oxygen because I've got 4 here plus 2 of them creates 6, and now we can see that our equation is, of course, balanced. So that's probably one of the examples of writing a chemical equation from a worded question. Now, if we go and have a look, this is, of course, the video for the sheet that's on Canvas, which is, of course, given the same name as the WOP, while writing chemical equations. But on that sheet are some other questions, and I'm going to do one, I suppose it's a little bit, well, it's kind of a trick question. So I'm just going to make this one up. So let's say that we have ethanol, and I heat this to, say, 90 degrees. Now, I'm not really sure exactly what the boiling point of ethanol is, but I'm thinking it's around 80 degrees, and I heat it for, say, 10 minutes. and then I distill the product. I distill the heated ethanol. Let's write it that way. It probably makes a little bit more sense. Now, the problem is that if you look at this, where you hang on, I've got ethanol on one side, and I've got ethanol on the other. And the reason that this is occurring is this is not a chemical reaction. This is what's called a physical reaction. So it's a change of state. So we've changed it from a liquid to a gas. And of course, we don't need a chemical equation for a physical reaction. So when you're looking at those particular things, just make sure there's a couple on that sheet that are designed there to trick you, and we'll just see whether or not you can pick them for a physical reaction rather than a chemical reaction. Now, just a quick shout out, I suppose. As I said, there were some tips and tricks. I'm just going to have to move my document camera, so bear with me, guys. So these are some of the tips and tricks, and I'll talk about them in just a second. And then over here, we can see that there's a list of our acids. Now, sorry if you just got massive accounts of motion sickness there, but yeah, as I said, I'm not a professional YouTuber, although I sound like it. I know stuff for kids, but I'm not, okay? Miss Moore's the professional on this channel. You may have seen her song. So, wow, if you definitely didn't get sickness from that, I'm massively surprised, because I was looking at the screen and I got sick. So I just want to talk about that diatomic gas, because this is probably where I see most of the time with kids just getting things or going a little bit wrong. Let's say that I was going to, well, let's do an equation for something that we've already done. So magnesium ribbon, is burnt in the presence of oxygen gas. Predict the products. I can't get that right. Sorry, kids. And what type of reaction? Oh, now that's a great question. Okay, so we think about this. We've got magnesium ribbon. Now, of course, remember when we did that, that's a solid. It's a metal, so I'm going to put a little S there to, of course, tell us that it's a solid. And then we're burning it in the presence of a gas, oxygen. Now, if you remember that said gases are diatomic molecules, remember when we looked at covalency, oxygen won't exist as a single element. It'll actually form a covalent bond. And if you're sharing electrons, you need someone to share with. And we call these things diatomic, so di meaning two, atomic meaning two atoms, molecules. So just be really careful. If it's burnt in the presence of, say, a gas, then it's going to be a diatomic molecule. And of course, we know that this produces the compound magnesium oxide. Now, we know that magnesium is a +2 and oxygen is a -2. As a subject of our report, and we knew that this made a powder, so I'm going to put a little S for a solid there. And I suppose the first thing I'm going to do is, first off, is this a balanced chemical equation? You're going to tell me, no, Mr. Robinson, it's not, because I've got a 2 there. And that's why it's really important that we remember these diatomic molecules, because if we don't put that 2 in, you would have told me that, of course, this was a balanced chemical equation. So to get 2 there, because 2 there gives me 2 oxygens to balance these 2 oxygens, and then of course I need a 2 in front of my magnesium, because I've got 2 magnesiums over this side and I need 2 magnesiums over that side. So by having a look at that, if we didn't know about this diatomic molecule, then we wouldn't actually be able to produce the right particular equation. Now, what type of reaction is this? Well, we have 2 things that are coming together to make one thing. So this is a synthesis reaction. Now, guys, I know this has been a slightly longer video than normal, but there were a couple of things that I wanted to point out. You might want to write that list of acids into your book, and of course you can go back and just pause the video. And the tips and tricks are probably another thing that you might want to write down. Anyway, catch you later, guys. Hope everybody's safe out there and working hard. Don't forget to do the worksheet on Canvas. Bye-bye.